solving quadratic equations, the null factor law. If a quadratic expression is said to equal y, so this quadratic here equals y, that creates the graph of a parabola. So every quadratic expression graphs a parabola. When I'm asked to solve a quadratic equation, it's asking for the values of x when the expression equals 0. X squared minus 2x, it's basically let y equal 0. So 0 equals x squared minus 2x. Now when y is 0, that is asking for the 2 points, or possibly 1 or no points, but we'll get to that later, where the parabola cuts the x-axis when it's graphed. Because you can see that there's 2 points in this parabola where y equals 0, we expect two solutions for x, this one here and that one there. The way that we solve a quadratic equation, if it's an expression, we let it equal 0. We factorize now, then we use the null factor law, which says if the product of two numbers is 0, then either or both of the numbers are 0. So that makes sense. The only way you can multiply two numbers and get 0 is if one of them is 0. If I was solving this is the product of x and x minus 2. Either x is 0 or x minus 2 is 0. So either x equals 0, this one is 0, or x minus 2 is 0. Now if x minus 2 is 0, we solve for x equals 2. So my solutions are x equals 0 or x equals 2. And for this particular parabola, it cuts the x-axis at 0, which you can see, for x, and 2 for x. So the null factor law, we use this when we're asked to solve. We let y equal 0, or let the expression equal 0. Let expression equal 0. Factorize. Now you would have to move it into into the general form, ax squared plus bx plus c equals 0 first, then factorize. Use null factor law. Excuse me. I'm going to sneeze. Now we just solved that one. X squared minus 2x equals 0, so I'm not going to bother. X squared minus 15 is 0. It's rearranged to have 0 on one side. We factorize. Now, this is one of those tricky third ones. X plus the square root of 15, x minus the square root of 15 equals 0. Therefore, x plus root 15 is 0, or x minus the square root of 15 is 0. Rearrange, subtract the root 15, x equals negative root 15 or x equals positive root 15. You'll notice that it's just whatever's in the brackets there with the opposite sign, but we do have to show the working for how we got it. Solve this one. Firstly, it hasn't been rearranged, so it equals 0. So 2x minus 50 equals 0. Secondly, always check for a common factor first. So 2 outside of x minus 25 equals 0. Factorize 2 outside of x plus 5, x minus 5 equals 0. Now when we've got a number out the front, we don't need to worry about it. Because yes, there are 3 products here, 2 times x plus 5 times x minus 5, but the option of 2 equals 0 does not work. So the only thing we have to worry about is x plus 5 equals 0 or x minus 5 equals 0. Therefore, x equals 5 or negative 5 or x equals 5. If we are asked to solve, so those were differences of perfect squares. Now we've got standard quadratics. Factorize. There's our x, need factors of 6, both will be negative, and that's minus 2 and minus 3. Therefore, x minus 2 is 0, or x minus 3 is 0. Solve these two equations, add 2 to both sides, x equals 2, or x equals 3. This is the full solution to that. Solving this one, factorize first. X at the start of each. Factors of 1 that add to give 2. Well, that's easy. X plus 1, x plus 1. Now, in this situation, you'd probably fully factorize just to be pedantic. There's only one possible solution. Therefore, x plus 1 equals 0, because that's the same in both brackets. X equals negative 1. Where you get solutions with only one solution, by the way, is where your parabola just touches the x-axis at negative 1. We will later on learn to factorize non-monic expressions, and we will factorize this by grouping. I will teach you how. For the moment, I'll just skip to the factorized form. So you would factorize your non-monic expression, and then, therefore, 2x minus 3 equals 0, this bracket, or 5x plus 1 equals 0. And it's a two-step equation to solve for each of these. 2x equals 3, x equals 3 over 2, or 5x equals negative 1, x equals negative 1/5. So two solutions again, using the null factor law. It's just that we do have to be able to factorize a non-monic